The surface distance between points. So I guess it's talking about the Earth surface distance. I don't know how you would know that between points C and D. C lies 30 degrees north of the equator. D lies 10 degrees south of the equator. So the idea here is you're drawing a little sector. This is the surface of the Earth. There's the equator. Not to scale. That's 30 degrees. That's 10 degrees. That's 40 degrees total. Is that okay
Um, yeah,
so far? All right.
yeah.
Um, the there's this relationship where they tell you that S, R, and theta are related by this, but theta is in what's called radians. So I don't know that it's like the best formula to use here. The circumference of a circle is 2 pi r. Maybe you know that from a previous course or previous math experience. But if you want the sector, which is this right here, the sector is the arc length. Yeah, you would have
Hmm.
learned that in geometry. Sorry, sometimes I forget what class you've taken. The sector is the angle out of 360 times 2 pi r. And I like this formula better because you're not like learning a new formula. You're just using circumference and you're thinking, well, if you go all the way around the circle, that's 360 degrees. 360 divided by 360 is 1, which becomes just 2 pi r, which is the circumference. And then you're not worrying about this conversion to radians, which I guess, again, maybe you saw that in geometry. I have no idea. I don't know if they emphasize it or not in your course. Um, so having said all, there's kind of two approaches here. There's the radian approach, which is what you did in your class, or there's just this approach. They give you the same answer. Um, do you have any idea which way you would like to do it or what you've been?
Oh, we've been doing S equals R theta.
Okay. So when you
Like
when you
that's what
use
she
that,
wants us to do.
okay. So when you use that approach, you have to convert your angle to radians. To convert from radians, you multiply by pi over 180.
Yeah.
Has to be in radians. And then the radius is given 3,963 times 40 pi over 180. Whoa. That is and that's what you have. You're missing a little notation. Be nice to see the S. And then I don't know, you round your answer to whatever they want you to round it to.
Okay.
Now, this next one, I mean, and some of these truthfully, like, I don't know, these are like you have to know a little bit about the Earth, I guess, and the lines. Um, the Tropic of Cancer, but like I believe if we were to look at a globe, the Tropic of Cancer is like a ring up here. Does that does that look at all like what you guys are doing in class? I gotta go look this up. I don't
Yeah.
remember. Um, so uh, what you can do, so like the circumference of this red line requires you to have this here and here
Hmm.
kind of triangle. And so like to me, you would maybe put that um but we have another angle. Okay. So that 23.9 is really here. And then the radius of the Earth is still 3,963. So you can find this R here. This is like the radius of that circle, which is kind of what it looks like you did. You did cosine of 23.9 equals R over 2963. You solve for R. And then once you get that, you find the circumference of that red circle. We'll go back to the red pen. Circumference is 2 pi R, and that's the R there. It's 2 pi times whatever you get from 2963 cosine 23.9. And that does look like exactly what you have done in that problem. Maybe
I
this picture is more helpful than what you saw in class?
yeah, that helps a lot, like the 3D, seeing it 3D. Because I was confused on what it meant by it's located 23.9 degrees of the equator.
All right. I need to just step away again for 30 seconds. It's a food
Okay,
thing. There's to
you're all
deal with,
good.
but be right back. Okay. Did you get like any sort of introduction to this in class? Like, did you guys look at a globe or
I was absent the day they covered this, which is why I was like struggling with this a bit.
okay. Well, that would be a good it'd be good reason to be confused, especially
Yeah.
but I mean I don't I mean this is more geography than anything. Quito, Ecuador, and Indonesia are both located on the equator. Find the shortest distance between the two cities. If Quito lies at 78 degrees west and P lies at 109 degrees east of the prime meridian. All right, so again, guess we'll draw a globe. So on this, they're on the equator. It says that they're both on the equator. And so like if we just say, okay, that's the equator, um, one is like 78.5 degrees one direction west, which I don't really know which way we're gonna call west. I guess we should go from the north. So let's say from the north, that's 78.5 degrees. So I don't know, like imagine the town's there. I don't know, it doesn't matter which one. And then the other one is 109 degrees east. Okay, so like maybe it's kind of there-ish. You follow that picture?
Yeah.
Okay, so to find the shortest distance between the two cities, what I can't tell you is if they mean like going around or through. Like you can do this many ways. but it looks like the way you solved it, it's going around the surface of the Earth, which is not the shortest, by the way. Like if you could tunnel through, which I mean, I don't know, it seems unreasonable, but yeah, I mean, that is the shortest distance. So what do you think? Did they literally mean?
Do they mean?
Like, do they mean going around the circumference, or do they mean like cutting through the planet?
I think it's going around the circumference.
Okay, that would make more sense.
Yeah.
So that is again, it's an S equals R theta situation. Your theta is 78.5 plus 109. And then and that's your theta, your radius is the same as before.
Hmm.
So the calculation you have is perfect. And you know, it's just the I mean it's all here. All right. What's the prime meridian? Parallel 50 degrees north of the equator. Okay. All right. So number 4. Okay, yeah, surface distance. See, this problem says shortest distance. So I actually do like if you were to ask me, I think that they want you to find this thing I've drawn over here, and it's this there's a little triangle here that we can do with a little hypotenuse, and we can figure this out, I guess what I'm saying. But because it doesn't say um like in number 4 it says surface distance. So I would ask your instructor,
Okay.
like just double check. All right, so find the surface distance between points L and M. If L lies 60 degrees west of the meridian and point M lies 45 degrees east of the meridian, both points lie on the parallel 50 degrees north of the equator. So again, we're going to draw our Earth, okay? And again, right from the center of the Earth, 50 degrees up like that is this meridian thing. Well, that's terrible. Sorry, let me draw that a little better. There's some sort of a circle here. Okay. So we
The
need,
meridian is the vertical.
I guess, I am not a, I'm not a, yes, it is the vertical. That's why I said you almost need a reference sheet. for this.
Yeah.
So we can draw a triangle here. All right. So if this is 50 degrees and this is 50 degrees, we know that this is 3963. We can figure out the radius there. Okay. So the radius, well, it's just like the previous problem. It's the cosine 50 equals R over 3963. So the radius is 3963 cosine 50. All right. Once you have that, that's the radius in this red circle. So this red circle has that radius. And that's where it's like point W is 60 degrees west. I know we're kind of changing views, but it's like 60 degrees west and then 45 degrees east. And then we're finding this S here, and this is the R. So the red is the top down view of the you know, if you could slice You know, I don't know if you slice the apple or the orange, you would see that.
Okay.
Okay, and this is on your paper. Like this calculation is there. I mean, it looks okay to me. You know, this is 105 degrees. So your S equals R theta. Your theta is 60 plus 45 times pi over 180 because you have to convert it to radians. Your radius is whatever this number was here. So you can wait till the end to calculate it, or you can do it, you know, in pieces, whatever you're comfortable with.
Okay.
Yeah, so five sort of adds to the confusion here. Five says shortest surface distance, which suggests that maybe number three, your teacher just omitted the word surface. You'll notice we have shortest shortest distance, surface distance, shortest surface distance. I don't know. I mean, I don't think there's a mistake, but that's just something to think about. Okay. So Q lies 90 degrees east to the prime meridian, and R lies 100 degrees west of the prime meridian. Both points lie on the parallel 30 degrees south of the equator. Okay. So again, we draw another globe. Here's the equator. And this time, 30 degrees south. So from the horizontal, 30 degrees south. I'll do it in blue. We're doing too much red here. So the points Q and R, um, yeah, we'll get to those in a moment. We have to first figure out the radius here. So just like before, another triangle here. So 30 degrees, 3963. You know, you're noticing a pattern here to solve for R. R is 3963 cosine 30. Like we've done that a bunch of times. So that's this blue radius here. And then again, you just draw a top-down view. And you notice I've been kind of going from the north here. You know, consider that way north, that's kind of standard. And it says 90 degrees east of the prime meridian. So that's 90 right there. That's wherever Q. And then the other one is 120 degrees west, which puts you west. So we actually want this angle in here this time, which is 150 degrees.
Okay.
Okay, so from here, we're going to, we got the R, that's the R down here. S equals, this is S, R theta. Theta is, 150 degrees times pi over 180. The radius we have from the previous part of the problem. .30, not theta. And then 150 times pi over 180. I hope there's not another page of this, but there is.
Yeah, the problems on the back are a lot harder.
Okay. Any questions on what we've done before we move to 6?
I don't think so.
Okay. Right. Um, why don't you, no, I guess it's, sorry, I'm trying to, I mean, it's the same drawing again. I guess it's like, I mean, it's kind of repetitive. I know for as a student, it doesn't seem that way, but once you get in the flow of these, it's really just drawing the same picture each time. And I hope you're trying as much as you can on your own to do that. Again, there's the equator. And so it says that 60-degree north parallel, to me, that means that there's a 60-degree right there. And then there's another circle like that we're trying to find.
What do they mean by parallel?
I thought they were, I'm gonna look. I thought they were the ones that go um e- east to west. Like I would say it's like if we to me the parallels are the ones that if you were to slice it this way and get those rings,
Hmm.
that's the parallels to me. Again, I'm just confirming that.
I think.
Yes, those are the parallels. They're parallel. So like we do this in English language, we just shorten things, but it really means parallel to the equator. That's what it really is.
Okay.
All right. Um, so we need to find this again, which, we've done a bunch of these, but it helps to, do them over and over. And this is 60 degrees. This is the new R. This is the 3963. So R is 3963 cosine 60. All right. Why don't you calculate that for us? Make sure your calculator's in degrees. Just round to the nearest ones place. We don't need it to be any more than that.
1981.5.
Let's go 1982. All right, so now if we do the top down, this again, so we're looking at this right here. It says that, and I'm going to go back to it on this other screen. Oh, come on, load up. All right. So 150 degrees west. So here we go again. There's the north. So 150 degrees west is there. And then the other one's 30 degrees east. Oh, that's nice. So this is Seward, Alaska. This is St. Petersburg, Russia. Um, so the distance between them is the diameter because it's a perfect, 180 degrees. So that's just it's 2 times the 1982. So that's thing one. So it says which distance between the two cities is shorter, traveling along the 60-degree parallel or traveling through the North Pole along a latitude? Okay, so that's a little weird. So sorry. So that's not what they're asking. Apologize. God, these are weird. These are really weird. Okay, they're asking first is if you were to go around the Earth, S equals R theta. They're asking that's option one. That's the standard one. So that's 1982. The angle is 180 degrees times pi over 180. Could you calculate that for us, please?
$6,226.6.
Okay. So that's traveling along the 60-degree north parallel. So that's this that's going around the 60-degree north parallel.
Why
The
would you
second
multiply by 180?
dividing by 180.
I mean, why would
Uh
you?
oh, because the angle. Theta is 150 plus 30.
Oh, okay.
All right. Now the next one's like weird. It says traveling through the North Pole along a latitude. It's like saying going this way, like that. Is that clear?
Yeah.
Okay. So to do that, it's actually like going back to kind of more of the original picture. It's a vertical sector like that, where if we were to add in another angular 60 degrees, this would be 120 degrees between them, and the radius is 3963. So this is another S equals R theta calculation. S equals 3963 times 120 times pi divided by 180.
It's 120 because
That's that like we're trying to build this vertical blue thing,
Mhm.
and we know that it's 60 degrees and 60 degrees to either edge of the parallel.
Oh,
Oh,
okay.
I'm sorry. So it should be 60. That's sorry. That it because the three of them add up to 180. So that's a good catch because I did not see that. So go ahead and calculate this for us, please.
4,150.
Yeah, and you're gonna see that that is shorter than this. So it's the second option. I mean, I think if
Could you
we
explain how you got the 60 degrees again?
yeah, so it's on a straight line here, so the three have to add up to 180. 60 is to the parallel there, 60 is to the other parallel, and then the three of them have to add up to 180 because it's a straight line. We really need like a three-dimensional shape to make this clear, like what we're doing. But it goes back to the original information. 60-degree north parallel. It doesn't matter whether you go right or left to get to the north parallel, it's 60 degrees.
Oh, okay.
Right. Move on to 7. Okay. Location in the Sahara Desert is at 0 degrees longitude and 30 degrees north latitude. How far is it to Shanghai, China, if Shanghai is at 120 degrees east longitude and also at 30 degrees north latitude? So I think it's just another way of asking sort of the same question that we've been doing over and over again is um, 30 degrees north is that, and then there's this, ring, some sort of a ring here, a circle again. And we'll get to that in a moment, but both China and, which I don't really believe, but maybe that's true. I mean, I don't know. I don't have a good sense of how far north or south of the equator things are, but Shanghai is at 100 degrees east longitude. Okay, 0 degrees. All right. All right, well, that's fine. So it's the same kind of setup here. You got this triangle here. We want to calculate the R 30 degrees again, 3963. So R is 3963 cosine 30, like that. And I think you already did that calculation a few times, but if you want to, you can redo it.
3,432.
Okay, go with that. And so now on this blue circle, sort of top-down view, that is not a good circle. It's a little better. So from the north, okay, so it's saying that the Sahara is right there. So that's, you can just start with that. And then China is 120 degrees east. So there's 120 degrees east. So it says, um, let's just say we need to find S, just like we've been doing. So S equals R theta. The angle is 120. You have to convert that to radians. The radius is what we just found there, 3,432. 120 times pi divided by 180. All right, so go ahead and can you calculate that for us, please?
7,187 point, oh wait, no, 7,188.
Okay. All right, so that's the distance if you go, surface distance, you go around the Earth. Now they're saying, uh, what if you could tunnel right through? So what if you could do, and I'll show it in red here, this right here. So I'll just kind of re-diagram this. There's that this is, geez, sorry, why I did that. This is the triangle. This is the 120 degrees. Okay. And then this is the tunnel. All right. And if you drop this straight down, this is 60, 60, and 30, and 30. And we know that the R is the 3432 because that's this radius right here. So we can calculate the X value. So we're trying to figure out like how far this is. We're going to calculate both X values and get that. So the cosine of 30, doesn't matter which triangle you use, is X over 3, 4, 3, 2. So X is 3, 4, 3, 2 cosine 30, and that'll give us half. Then we're going to double it to get the other half. So go ahead and calculate this, and then we'll get the total the tunnel. The tunnel will be
2,972.
all right. So the tunnel is 2 times that, and we shouldn't be surprised that it's much less than the previous. The tunnel's going to always be faster.
5,944.
Sorry, 5,944. Yeah.
Yeah.
So this one is preferred.
Could you explain, like, could you graph out both the Sahara Desert and Shanghai?
Yeah, I mean
Like,
so let me, yeah, I'll try to go back here. So here's Shanghai. And if we go back to the original, uh I don't know exactly, but like imagine one is, well, I'll just put one there. One is like
because
the
one's at 0 longitude and the other's at 120. So I was wondering how that would look.
0 degrees. I mean, it's like pick one, whichever one is, if that's 0 degrees, then the other one's like over there.
Where?
I'm trying to, it's hard to do 3 dimensions on this. Like again, there's a ring, and then like one of them's there and one of them's over here. And like in terms of like on the globe, like one's there and then one's on the ring, but over here, 120-degree angle apart from them. It's really hard to
Oh,
explain. I mean, I
okay.
okay. I think we can get the last one done. Oh boy, I I really hope the students in class got a globe or something you could look at. But all right, so an engineer has proposed to build an underground tunnel directly from Los Angeles to New York City to house a high-speed train. From the Earth center, the angle between the two cities is 35.2 degrees. So like you can keep it really simple on this one. There's New York, there's LA, there's an angle of 35.2. The radius is 3963. So you can just calculate S. S equals R theta. And so it's 3963, and then it's the 35.2 degrees times pi over 180. So that's this first one.
2,435.
Okay. All right, so now the next one says, how far below the surface of the Earth will the tunnel be at its deepest point? So that's like drawing this right here and then figuring out um, this right here, this little H.
Okay.
And I mean, there's the way to do it is to recognize that um, the whole length in red here is the radius, but you just need to find this right here. So it's actually another right triangle. And so I'll draw that. It's 35.2 cut in half is the angle. That's the angle. This is still 3963. And we want to find, I'll call it Y this time. So this is 17.6 degrees. So it's the sine of 17.6 equals Y over 3963. So this is Y, by the way. Y equals 3963 sine 17.6. Gonna calculate that.
$1,198.
Okay, now to get to get this right here. Oh, sorry, oops. Maybe we need oops. Uh oh, actually we do need that. Sorry. Sorry. So what we calculated actually is this is actually the surface distance. The Y, 2Y is the tunnel. Sorry about that. Sorry about that. So the tunnel is this 2Y. 2Y is the tunnel. S is the surface distance. We still need to figure out this thing right in here, which we're going to get to. So the tunnel, which is, sorry, all the scrolling. Tunnel is right here. Tunnel is 2Y. So you can calculate that. Whatever that is, it's 2396. And so we actually do need to get this X right here we can get from a cosine. So X is equal to 3963 cosine 17.6. If you could calculate that for us.
$3,777.
Okay, so this little H here, I'll call this H. This H is the radius minus X. It's 3963 minus 3777. That is that's what they're looking for in that second part. That's the how far will the surface be at its deepest point. Let's see here. 37. 100. Like one. You have this 38, 463, 189, something like that.
And that would be
So that's this middle one. That's this H right here. This H is the shortest distance from the air in the Earth. The blue is the last part. How long will the tunnel be is 2Y. And this H is how far below the surface it'll be. Pretty deep. I don't know if these numbers are true, but okay. As much fun as this is, which I don't know if you agree, we do have to stop there for today.